News Corp is using Spot instances in their own environment, and she has some fantastic slides explaining in detail about how they're being used. Okay, so how will this go? So first we're going to spend some time learning about EC2 Spot instances, understanding what they are. We'll talk a bit about EC2 Spot instances best practices. We will cover some tools for managing Spot instances. And then finally, we'll jump into this great case study with News Corp and JD. Okay, so let's cover, first of all, how we can consume EC2 resources on AWS, right? So the first two models on this slide are probably something that you're familiar with, on-demand consumption, right? This is where you pay for your compute capacity by the hour. No long-term commitment. It's really like electricity. You turn your instances on, you pay for the number of seconds that those instances run. When you shut them off, you stop paying for them. And it's great for spiky workloads and when you're in the mode of really starting to define the type of workloads that you'll be running on AWS. So once you've sort of locked in and have a good understanding of the types of workloads that you'll be running on AWS, it really makes sense to think about utilizing reserved instances, right? So this is the ability to reserve physical capacity in our data centers for a 1 year or a 3-year period of time. And this is, allows you to receive a significant discount off of the on-demand price. So the third consumption model is what we'll focus on today, is what we call the spot market. And this is where we allow you to bid for the unused on-demand capacity in our data centers. Spot instances are fantastic for time-insensitive workloads, for transient or stateless workloads, but they're also really great for running your production-style workloads as well. And JD will talk a bit more about how some of the best practices and some of the systems and services that they've come up with to allow them to deploy Spot instances in their production environment. So let's understand a bit about capacity, right? So AWS has millions of active customers. That ranges from large enterprises, startups, public sector organizations, every imaginable customer and use case you can think of. So what does that mean? That means we need to have a lot of spare capacity in our data centers to allow our customers to scale when they need to scale, right? But we don't want that extra capacity just sitting there. So what does this mean? This means that we've enabled that spare capacity to be available to you through something called Spot instances and the spot market. And at the end of the day, EC2 Spot instances are really simply spare EC2 on-demand capacity with a couple of very simple rules. So if you only come away with 2 things today from this webinar, I hope that it's a good understanding of what these very simple rules of Spot are. Right? So the first rule is that Spot instances run in a market where the price of the compute changes based on real-time supply and demand. So as instances are spun up on demand and the spot market, and as they're terminated, that has an impact on the real-time supply and demand, and therefore the market price of these spot instances. The second is that you'll never pay more than what you bid for a spot instance or a cluster of spot instances. You have complete control over how much you're willing to pay, and at any point, if the market price exceeds what you're willing to pay for that compute capacity, we give you a 2-minute warning, and you have a choice when you launch the instances of either those instances being stopped or terminated, and we'll handle that for you automatically. Either way, we'll give you a 2-minute warning so that you can wrap up your work, you can save your state, you can checkpoint your job, you can do whatever you need to do to handle that. Maybe it's detaching from a load balancer, maybe it's copying some data to S3, whatever it is that you need to happen, and we give you that 2-minute warning. In the case where you've stopped your instance, Spot will actually turn your instance back on when the market price has decreased below your bid price. So since spot instances typically cost 50 to 90% less than on-demand instances, it's really the best way to get the best value for your EC2 capacity, right? So some customers have said, I really wish I could increase my compute capacity, but I just don't have the budget for it. Well, when you think about it, if you can save 50 to 90% off of that same EC2 compute capacity that you were running with on-demand instances, you can immediately increase your compute capacity by 2 to 10 times without changing your budget, right? It's a really powerful thing once you start to think about it and how you can apply and utilize spot instances in your environment. Some customers say, well, I really don't need extra compute capacity. I'm happy with what I have, but it sure would be nice if I could reduce my bill. So, flipping to spot instances in these cases is another great way to save 50 to 90% off of your existing workload. Many customers will do a combination of both. They'll add compute capacity for maybe another dev test environment or that QA environment or that staging environment that they've always kind of needed but didn't have the budget for. And at the same time, they will also save money off of their existing environment, right? So, either way, I think spot instances are a fantastic way to utilize cost-effective compute capacity, and I really hope that you're able to give it a try to use spot instances in your own environment after spending some time with us on this webinar. So again, to better understand capacity on the AWS end, I have this slide that I'll explain here, right? So I've chosen a region in Northern California, the US West 1 region. This region, and every region has at least 2 different availability zones, right? Every region has 2 or more availability zones. So obviously these are separate pools of physical capacity, right? But if we start to slice it up along those vertical lines, right, we see each of those instance types, right? So P2s, C4s, M4s, for example, these are all separate pools of physical capacity in our data centers. And then if we just slice it up a little further, right, we'll see the different sizes within those instance types are also separate pools of capacity, right? So the C4 4 extra large is a different set of capacity than the C4 2 extra large. So what this means is that every single one of these little rectangles you see on this slide is a separate spot market, right, with different pricing and different levels of compute capacity, right? So this compute capacity is then unlocked and given to you to bid on with the spot market. Right, so let's take a look at this compute capacity and the spot markets from a different angle. Right, so I'm looking at a graph here of the C4 instance type. Along the top, you can see 3 different availability zones: 2A, 2B, and 2C. On the right there, you have the on-demand price, and then going down, you have the different instance sizes, and you can see that each availability zone has a separate and fluctuating price for that spot market, for that instance type. And just because the price for a given instance type in one AZ may have increased, that doesn't mean that the price will increase in the other availability zones. So if you happen to be running a C4 4 extra large in US East 2B, and you said, 30 cents is more than I'm willing to pay, well, by all means, start looking in the other AZ. So you can see that it's cheaper in 2A, and it's even more cheap in 2C. And so, right, these are all available to you. You can simply hunt around and find the best price for the capacity that you're after. So just to sort of recap that, right, each instance family, each instance size, each availability zone in every region is a separate spot market. Okay, I mentioned earlier the concept of bidding, so I want to make sure that everyone also comes away with a good understanding of what bidding means in relation to spot instances. So we have the concept of bidding. This is where you essentially say, this is the maximum amount that I'm willing to pay for a given unit of capacity. But what's really critical to understand is that you never pay more than the market price. So your bid price could be, for example, equal to the on-demand price, but you ever only pay what the market price is by the hour. So in this case, I'm showing a week's history of spot pricing for the R3 4 extra large over I said a week in the US East 1D region and availability zone, right? So it was hovering just under 20 cents per hour. You can see there were a couple of spikes there, right? So if we think about bidding strategies, had you bid 25% of the on-demand price, you only, again, would have ever paid what that green line required you to pay, because you only pay the bid price, the market price. But the bid price is essentially what you're willing to spend for that compute capacity. And so every time the green line exceeds that 25% bid line, those instances would have either been stopped or terminated, depending on what you chose. Had you bid 50% of the on-demand price, you would have only experienced one interruption in your spot instance over that week's period of time, and really not paying much more than if you had bid 25%, because again, that green line is what you pay. Had you bid 75% or equal to the on-demand price, you would have received 0 interruptions over that week's period of time. Your instance would have continued, again, without interruption, and you really would have not paid any more than if you had bid 50%. So what I like to say is, don't think too much about bidding. Think about what your maximum price is that you're willing to pay. I say, just keep it simple, bid 100% of the on-demand price. The worst case is that you would pay the on-demand price. Best case is that you would be saving 80 to 90% off of that on-demand price. So that bid price, especially in relation to bidding equal to the on-demand price, that's how much wiggle room you have for the spot market price to fluctuate. If at any point that green line were to exceed your bid price, again, your instance would either be stopped or terminated, depending on what you've chosen. So when we talk about best practices while utilizing spot instances, there's a lot of overlap with just general EC2 best practices, right? Regardless if you're running on-demand, spot, or reserved instances, you still want to follow these 4 best practices, right? You want to be stateless. Your applications should not maintain state on the local instances as much as possible. You want to keep state somewhere else, whether it's a DynamoDB table, an RDS database, or something like that, an Elasticache layer. You don't want that state to live on your individual instances, right? You want to design for fault tolerance. You don't want to have a single point of failure in any component of your application. You want to utilize multiple availability zones as much as possible. You want to spread load across availability zones, and you also want to spread capacity across availability zones. You want your applications and your architecture to be loosely coupled. So the goal here is that if you need to increase either capacity or some sort of component of your stack, you don't want to have to increase components for all pieces of your stack just because one small component in the greater stack needs additional resources. So if your database tier needs more memory, you don't want to have to increase memory for the web tier as well. You want everything to be very loosely coupled. So the last best practice when it comes to spot instances is something called instance flexibility. So what this means is, take a look and have a good understanding of which instance types and sizes your application stack can use, right? So many customers don't think about the fact that if you're currently using C4 extra larges for your application, well, it's more than likely that going up a size to a C4 2 extra large probably won't hurt your application, right? It may not be that you can take advantage of the extra resources, but there's a very good possibility that the price of a larger instance size on the spot market will be cheaper than the same smaller instance size on the on-demand purchasing model. So it's important to think about that flexibility, right? Saying, can I use, maybe another instance type or 2 in my environment, whether it's a different size or even a different type? Make sure that you're using multiple availability zones, because again, each of those is a separate spot market when you think about it. So cross-referencing availability zones along with instance types and sizes, you can come out with a lot of different instance capacity pools that you can pull from to utilize on the spot market. So let's talk a little bit about another best practice, which is diversification, right? So I said instance flexibility in the last slide. in this case, let's talk about diversification across instance types, right? So as best you can, consider selecting multiple instance types, utilizing multiple availability zones. And if your application stack, for example, is something that needs to have similar performance characteristics across the stack, consider looking horizontally across multiple instance types, but with instances that perform with similar characteristics, right? So something like targeting 3 different instance types, but all of large sizes, so that C for large, R for large, M for large, these all perform somewhat similar and more than likely can adequately handle the performance that your application needs. For those of you that have said, I have instances and I have applications that need to run continuously without potential interruption for a period of time, we do offer something called spot blocks or defined duration spot requests. And these spot blocks can run continuously for anywhere from 1 to 6 hours. The discount off of the on-demand pricing is not as steep as spot instances themselves. However, you still receive roughly 50% off of the on-demand price. Using spot blocks and requesting a defined duration is simply another parameter when you're requesting a spot instance, and it's really just passing how long would I like this instance to run for what duration. And so in this case, if you had said, I would like my my spot instance to run for 360 minutes, we take a look at our capacity. If we have it, if we think that your instance can run uninterrupted or instances can run uninterrupted for that period of time, we will go ahead and fulfill those spot requests, those spot block requests for you. Those instances will appear in your account and you have access to them. If at any point you terminate a spot block before the duration that you requested has been reached, we stop charging you and you pay for the amount of hours, minutes, and seconds that the instances actually ran. If the instance runs continuously for the defined duration, when it's finished, we will terminate that instance for you automatically, so you don't have to worry about instances running out of your longer than what you've requested them to run. Okay, so I just told you about all of these, the great functionality that spot instances allow you to have, but I've also said, you need to hunt around and you need to find that capacity, and you need to find the best prices to get the best sort of bang for your buck with spot. So I don't want you to worry about that too much. I don't want you to focus on that too much. What I wanted to explain to you is a tool called EC2 Spot Fleet. And EC2 Spot Fleet is a tool that helps you launch thousands of spot instances with a single API call. And I say thousands, it could also be one, right? So it's a tool that allows you to spin up your spot resources from a single API call. It has a lot of different functionality built into it. One of that great tools that it has built into it is a couple of different allocation methods, right? One allocation method is get the best price, right? Find the lowest price. So in this mode, maybe you want to think about running something like a batch compute job or some net amount of horsepower that you need to get done. You want to use a spot market for it, and you just want to find the rock bottom lowest price on the spot market. So in this allocation mode, you can say, just go out and find me, net number of instances, find me the cheapest price, and spin those up and maintain that capacity for me. On the other side of the house, if you're running a workload that needs to be maintained and maybe is backing a type of a resource or application that needs to have a given amount of availability backed behind it, you can tell Spot Fleet to go into what's called diversified mode. And this is where Spot Fleet will diversify as best it can across availability zones that you've allowed it to use, across instance types and across instance sizes, all while still keeping best possible cost in mind. And so either of these methods really unlocks the potential of the spot market to you and lets you choose and pick which resource allocation method works best for you. if you are able to diversify across instance sizes, vertically as well. So if you have allowed Spotfleet to say, please consider launching on extra larges, 2 extra larges, 4 extra larges, and 8 extra larges. Clearly, these will be spinning up different amounts of raw capacity for you, different amounts of CPU, different amounts of memory. In that case, what you can do is you can apply custom weighting to your Spotfleet to tell it, hey, I've allowed you to spin up different sizes and different pools of capacity, but an 8 extra large is equal to 2 4 extra larges, so that it doesn't imbalance your net amount of capacity, right? So you can tell it, rather than spinning up number of instances, you can say, I'm telling you that an 8x is worth 2 4x's, and therefore, go out and find me this amount of virtual CPU capacity or this amount of memory capacity, and Spotfleet will go out and do that for you automatically. We also have something in the published on our website, right? It's not even in the console; it's just embedded in our documentation. It's a nifty tool called the EC2 Spot Bid Advisor. The Spot Bid Advisor, the job of the Spot Bid Advisor is to allow you to get insight into, what if I had bid this amount of money for this instance type in this region? What would have happened based on historical pricing data? So this Spot Bid Advisor, again, lets you say, my operating system is Linux or it's Windows. I would have been willing to bid 50% of the on-demand price in this case, or 75 or 100%. This is the region that I'm looking at. What would have happened here? And so the Spot Bid Advisor pulls from the Spot History API. It comes back with some suggestions about what would have happened over a month's period of time or a week's period of time. So in this particular case, it's returning to us that the M4 extra large would have run continuously without interruption over a month's period of time and a week's period of time, all while saving you 90% off of the on-demand price. So it's a very, very handy tool that lets you have some insight. We also do publish spot pricing history through a spot pricing history API that you can query. It gives you pricing history for 90 days. You can write your own tools against it if you would like to get some additional insight into pricing history for your own applications and your own environment. But again, you can start by looking at the Spot Bid Advisor just to get a ballpark idea about how those instances are performing in that particular region, and sort of the expected cost savings based on historical pricing. Obviously, this cannot predict the future, but it does give you some good insight for how things have been providing steep discounts over over the last month or week. So we also have a GitHub repo where we publish open source tools that allow you to take advantage of the spot market. Here's an example tool, a tool called Get Spot Duration. It's a Python script. It's really doing roughly the equivalent of the Spot Bid Advisor that I just showed you, but it's a command line thing. It's in Python, and it uses the the AWS Python SDK to pull that information from the pricing history. And so in this case, I'm just showing you a screenshot of the output where it's showing you what would have been the expected duration of these particular instance types in these availability zones. So you can see that's number of hours that the instances would have run in those availability zones based on the price that you provided it. So we also have an even newer tool that's actually embedded directly into the AWS console, right? So you'll find this Spot Advisor directly when you're in the EC2 console and you've chosen to launch a spot instance request, or to put in a spot instance request. And the Spot Advisor is a pretty cool tool, right? So it lets you say, I'm thinking about running a batch job or a MapReduce job, right? Hadoop or Spark, or maybe a web service. This is the amount of CPU that I need from a virtual CPU perspective. This is the amount of memory I need. This is my platform, and this is how much capacity I'm after. And Spot Advisor will go back and it will return to you what it thinks you should use, right? So it returns a list of recommendations, number of each of those instance types, which availability zones it thinks you should use, and then it tells you what your estimated hourly price is for that spot fleet, and then it shows, in this case, that's translating to 83% savings off of the on-demand price. And so if you proceed through this configuration, that's really all there is to it. It can then start spinning up your resources. You can save this configuration file into a JSON formatted file that you can download, and you can simply use that JSON file for the next time that you're going to spin up some spot fleet resources. But again, this tool lets you think less about bidding, less about designing your spot fleet, and more about architecting your spot fleet to meet the exact requirements of your particular workload. All right, so let's take a moment to think about what types of workloads customers are using spot instances for. And so I put together a list based on the many conversations I've had with customers that are currently using spot instances. So I'll just go down this list for a few minutes, right? So queue and batch-based processing. This to me is sort of the no-brainer of using spot, right? You have these transient workloads. You have a requirement to get some amount of computing done, and so spinning up and spinning down spot resources based on the amount of work in a queue or a batch-based system is really one of the easiest ways to get started with spot instances. I have a CloudFormation template that I've published to that GitHub repo that I'll link to in the end. It shows you a demonstration of spinning up and spinning down spot fleet based on the amount of messages in an SQS queue. And spot fleet, has native abilities in it that allow you to scale up and scale down that spot fleet with an auto-scaling functionality, right? So your typical CloudWatch, Cloud Metrics, and CloudWatch alarms that all feed into powering this cluster and allowing it to scale up and scale down. Elastic MapReduce, so big data workloads, Hadoop, Spark, etc. EMR has fantastic ability to natively spin up your Hadoop cluster on spot instances directly through EMR. They just released, they being the Elastic MapReduce team, the EMR team, released a new functionality called EC2 instance fleets or EMR instance fleets, and EMR instance fleets does a fantastic job of taking inputs that you provided, such as these are the amount of spot instances I would like to use, these are the amount of reserved instances I would like to use. Please use them to power my EMR cluster. And so we do have a tremendous amount of people that are using spot instances to power their big data workloads on EMR and even outside of EMR. So we have a good subset of customers that are running their Hadoop workloads with spot instances as well. So stateless applications, right? Web tiers, especially web tiers that follow the traditional, 2 or 3 tier pattern. You've got a load balancer in the mix. You've got an auto-scaling group of web servers or application servers, right? They're all stateless. They can scale up and scale down based on real-time demand. These are fantastic use cases for spot instances as well. So when you start to combine things like Spot Fleet with load balancers, whether you're using our load balancers, ALBs or ELBs, or your own load balancers, again, these are all quite easy use cases and powerful use cases when you think about getting access to cheap compute capacity at scale. CI/CD pipelines, continuous integration and development, right? We have a lot of customers that are using the EC2 Spot Fleet Jenkins plugin. It's a plugin that you can find online. You can enable it in your existing Jenkins deployment. What it does is it allows Jenkins to send jobs into a fleet of spot instances that are powered by Spot Fleet, and that fleet will essentially scale up and scale down based on the number of jobs in the job queue in your Jenkins cluster. So if that sounds interesting to you, take a look for that Spotfleet Jenkins plugin. It's quite easy to enable and quite powerful. Again, allowing you to utilize your build pipeline on top of Spot instances. Containerized workloads, right? We've seen a great adoption, an increase of adoption of running containers on Spot instances, right? So the containerized managed service ECS, the EC2 container service that AWS provides, is a great tool to be combined with Spotfleet, right? Spinning up and spinning down your containerized workloads on top of Spot instances makes a lot of sense because your containers by nature are also stateless. And so combining a stateless containerized application on top of stateless instances with Spotfleet makes a tremendous amount of sense. And we also even have customers that are doing, live and on-demand streaming of content being backed by Spot instances, right? When you think about it, transcoding video takes a lot of CPU and GPU capacity, and so customers have really locked on to the benefit of doing their video encoding and transcoding, their large render farms running on Spot instances. So as I head to my last slide, I just wanted to demonstrate a reference architecture here that is showing, an example of running an Amazon ECS cluster, a containerized cluster on top of EC2 Spot instances, and so combining the power of ECS, right, the EC2 container service on top of Spot instances, and then you start to combine CloudFormation and CloudWatch, which allows you to scale up and scale down your compute capacity based on the amount of applications or containers or whatever it is that you're running within your containerized environment. These are very powerful design patterns that we're starting to see more and more in our customer environments. Okay, so I'm now going to turn this presentation over to JD Liu. I'll let her introduce herself. Again, she's a DevOps engineer with News Corp. I think she has some fantastic insight into how News Corp is currently using Spot instances in their environment. JD, I'll turn it over to you.
Thank you, Chad, and hello everyone. So I'm going to talk about our Spot solutions in News Corp, and we called it Spot On. So News Corp is one of the Australia's largest media companies, and our products span newspapers, magazines, publishing, internet, films, and so on. So I'm going to share our experience and license. So the idea is to give you more confidence to start using the Spot fleet on your productions. So when we developed our solutions, there were a few challenges. The first one was how do we attach the Spot instance to a load balancer? So currently, Spot Fleet does not support registering Spot instance with a load balancer. We have to run a script in the EC2 user data to get it work. The second one was how we can associate elastic IP address to a Spot instance. We have some services which require to have direct connections to the internet, such as the net host or the proxy services. There are two solutions at the moment to implement that. One is to use the Spot user data with allocating public IP script, but this is a little bit more complicated. An alternative way is to enable the automatic public IP addressing, but this is VPC WAS settings, which is not suitable for our case. So we have to run another script in the EC2 user data to get it solved. The third challenge was how do we deregister a terminated Spot instance from the load balancer? As the Spot instance have a roughly 2 minutes warning window when they're about to be terminated, so we need a mechanism to ensure that the elastic load balancer traffic is not routed through an instance that is about to be terminated. Luckily, there is a well-documented process from AWS. The idea is to run a script that pulls the instance metadata as a cron job for this termination warning. So the first one was what happened if the spot market price goes up beyond our bid price. This has to be considered if we are to have any guaranteed of services, especially for our production environments. So handle the outage or running on-demand instance in parallel are the quick answer. But deploying a diversified spot fleet helps a lot here, but there is still a chance that all markets in the spot fleet could be outbid. So surely there is a better way to do this. We find each spot fleet request has an associated CloudWatch matrix called eligible instance pool count. This matrix indicates how many individual spot markets that a spot fleet request could fulfill. So we configure a CloudWatch alarm that triggers when the number of the eligible pool drops below a certain threshold. For example, 2 pools. So then this alarm triggers a Lambda function is invoked to manipulate the auto-scaling group configured and provision the on-demand instance. So when the alarm status turns to be in OK status, the same Lambda function will remove the on-demand instance and leave the spot instance to handle all the traffic. So the fifth one was if my workload running on the T2 instance type, what should we do? So currently there is no spot markets for the T2 instance. That meaning the workloads may have to run on M3 medium instance or the larger instance type in order to take advantages of the spot. From the spot price history, you can find that there are lots of cost savings even using the larger instance type compared with the on-demand T2 instance. Deploying the spot fleet across a diversified range of pools means that we don't need to be constrained by a particular instance type. Also, it's quite rare that a workload has bad performance with running on the more resources instance. And the last challenge was how we can automate all of this. So this has to be considered if running the workload for the production environment. In our automation team, we run a few Lambda functions to handle the failover to on-demand instance and ease the complexities of the building spot fleet request into the CloudFormation stacks from operation and development teams. So in the next 2 slides, I will show you how we deploy the spot fleet stack and how these Lambda functions work. So we use Bamboo for our deployment when the plan is initiated. So the first Lambda function is triggered and it converts the on-demand existing CloudFormation template into the one with additional spot fleet resources required. After that, the second Lambda function is called with the user input, for example, the desired instance type or the bid price. Based on this information, it automatically calculates a list of pairs with a bid price and the instance type. Then the provided list is passed to the third Lambda function, which generates the final templates and upload to S3. Then the CloudFormation will grab this template from the S3 bucket and it creates the stack based on this template. So in the next slide, I will present how we handle the spot termination. So firstly, after bid is fulfilled, spot instance registers itself with the load balancer by the user data. Secondly, if the spot instance fails due to the outbid, the signal is assigned via the instance made data. A script we're talking about before pulls this information and points in the health check for the load balancer. After 2 minutes, the instance is terminated, so the CloudWatch event triggered, and it invokes the Lambda function to deregister this terminated instance from the ELB. So the spot fleet launches a replacement of the spot instance to meet your capacity. So thirdly, as we talked before, the the metrics of the eligible instance pull count drops, CoreWatch alarm will trigger a Lambda function that modify on-demand auto-scaling group to maintain the capacity for our workload. Lastly, another situation is that if the spot instance is in the pending fulfillment status for more than 5 minutes, the same Lambda function is triggered again to launch the on-demand instance and to make sure that our production can running smoothly. Finally, as in the News Corp, we heavily focus on the cost savings and the productivity for each team. Our automation teams spend a lot of time to build automatic way to implement this solution. Regarding of the spot-on adaptation, we firstly rule out cross non-prod applications, also giving enough transparencies to each team to help them understand the mechanism behind the scenes. This builds the confidence for our team to implement on the production. So far, we have migrated more than 25% of our production workload on the spot fleet, and we did not meet any critical outage by running the production on the spot instance. At the same time, the cost savings is huge to the business as well. So overall, it has been a very pleasant journey with running all this on the AWS Spot instance. So this is the end of my talk, and thank you very much.
Thank you so much, JD. That was